Now in this video, I want to talk about some military, commercial, industrial technology that needs to be brought down to the consumer level so that it's a little more affordable for the rest of us. Now, probably sounds a little bit boring, but it's going to be about the very best intrusion detection perimeter security devices and undetectable, unjammable communication. So I think that's pretty interesting. As you probably can already tell from, the thumbnail and the title, we're talking about fiber optics. Now, fiber optics are not new, amazing technology. This is stuff from a long time ago. In fact, I want to refer to an ancient National Geographic, which unfortunately I don't have anymore, but early in 1984, National Geographic had an issue all about lasers and the amazing things that they would be able to do, and fiber optics that could direct laser light to specific places for surgery, communications, and all kinds of amazing technology. And I'd like to point out that in this issue, over 40 years ago, they even predicted using lasers to communicate information, targeting information to drones that would carry munitions to targets on the battlefield. There's really, nothing new under the sun. If National Geographic was writing about the potential military applications of a technology 40 years ago, yeah, it's fairly mainstream. But over time, as is often the case, a number of these technologies actually came about. All of these things were basically delivered on. And communications technology has been using fiber optics a lot. This video, as soon as we finish it, we're going to upload it to the internet over fiber optics. You're using fiber for all kinds of stuff, and in many ways it has gotten way cheaper. You can buy, right now, a fiber network interface card for a computer for about 30 bucks, and then decent fiber to connect it to other computers and have lightning fast communication. 20-30 cents per foot to connect those things together, super long ranges. So in many ways, the prices have come down. The technology is available to consumers, and there's a whole bunch of ways in which that's playing out in the consumer technology space and on the battlefield. We've talked about drone warfare at length, mostly revolving around how it's playing out on the battlefields of Ukraine. And it is as much of a game changer as the tropes and the stereotypes make it out to be. But there's a very interesting thing that has happened. In the arms race between FPV drones and counter-drone technology, there's been a lot of signal jamming and signal spoofing and signal hijacking and electronic warfare going on. And one of the counters to this on the aerial drone side is to use fiber optics to control drones. There are drones that look like they're carrying like a 1-liter bottle packed full of optical fiber, and as they fly, it unspools a mile or two of this stuff, and all the communications back and forth between the controller and the drone happen optically. That means there is zero RF signature from the control signal or the camera feed at all, and there's no way to jam it or interfere with it. And certain parts of the Ukrainian battlefield are so bestrewn with this stuff that you can see it just hanging from trees and branches. So yeah, the military applications are there as well for this super cheap optical fiber that you can just buy by the mile and use to control little tiny cheap disposable FPV drones. However, I want to talk about some of the other capabilities that may or may not be getting fully utilized. And one of them is communication. Obviously, anytime there is RF communication, there is an opportunity to intercept it and detect where it is happening or to jam it. And I don't want us to get too far ahead of ourselves in this modern space age 1980s National Geographic technology. I want us to think about what is actually necessary to accomplish the mission. And sometimes a wire or a cable is the way to do it. If you guys remember your World War II history, the Battle of the Bulge was a particularly difficult time for the American forces, particularly 101st Airborne during the Battle of Bastogne, which is a fantastic episode of Band of Brothers that you should watch. Now, there's a lot of reasons that that was a particularly hard battle. One was environmentally, winter was there, and it was a cold, hard winter. The other was, as the Americans pushed the Germans further back into their homeland and onto their own turf, they had better fortifications and knowledge of the terrain, and that home court advantage. But one aspect of this that is talked about less is they had, in addition to their physical fortifications, they had built in some communications infrastructure. The Americans were used to being able to intercept and do a lot of signals analysis of German radio communications. And once they got back into some of their fortifications, they started using old-fashioned World War I era field telephones that communicated over copper wire that had been laid ahead of time. That meant no signals intelligence could be performed on the German troops. They had really good operational security at that point, giving them yet another advantage. So I want us to think about some of the ways where, as good as RF technically is, as great as radio communications are, sometimes an undetectable strand of copper, or an even more undetectable strand of glass fiber, might be a better way to do certain type of communications. Maybe it's high-speed advanced stuff like FPV drones, or maybe it's just really basic stuff like telephone. And while we're talking about the past, I also want to bring up Vietnam. I'm not old enough to have flashbacks from Da Nang, but I do occasionally get flashbacks from hanging out with Vietnam vets at gun shows and prepper conferences, and one of the things that they taught me about were geophones. In Vietnam, in order to detect people inside of the jungle, particularly a guy named Charlie, they would use different seismographic sensors. Some of them were big lawn darts that they would drop from aircraft and emit a radio signal based on activity nearby, and no one ever actually figured out how well those worked. But there was also a device called a PSR-1, I believe, which was 4 separate geophones that you would stake out around your perimeter and run cables back to a single listening device. And what the geophones would do is it was basically a big magnet suspended by 2 or 4 magnets, and as there were vibrations in the ground caused by walking or crawling or any type of vehicle movement, the magnet would move and it would turn that very low frequency electrical signal into an audio signal that you could hear. So the box that you had at your base had a loudspeaker so you could hear people that were coming, or if you were using it for surveillance purposes, fancy headphones. They had really good headphones back in the 70s. Now, I never got to use one of these devices as it was intended, but they were very popular amongst the proper old school preppers who had used these things back in the jungles of Vietnam. And this is a technology that I want to get back to because I live in the jungles of Tennessee. I don't want to compare like different rainforests and bugs and humidity and so forth, the different Charlies that we have here, but sensing movement with cameras and other sort of modern sensors doesn't really work as well in a place where everything is moving. Every leaf, even when there's no wind, is just swaying under the weight of bloodthirsty ticks and various other bugs that are waiting for you. Every single piece of the ground is moving as snakes and other crawly critters are moving along, waiting for human flesh. So yes, that is the Tennessee jungle. There are a whole bunch of modern sensors that are just kind of not ideal for what I'm looking for just for my property. I have some magnetic sensors out on the driveway, and those work great for vehicles, but I would love to get some seismic sensing capability for intrusion detection of my perimeter. Now, there are newer devices than those old 1970s seismographic geophones. Your cell phone has a number of solid-state accelerometers and gyroscopes inside that actually are far more sensitive at detecting things. So one of the things that's been on my to-do list is to build a perimeter detection system out of those. But I think that there is a better way, and once again, we need some of the humble optical fibers. There are really fascinating perimeter defense systems that are just a single strand of optical fiber that runs up to about 50 miles, and you can run it along a fence line, or you can bury it just on the inside or on the outside. And then, based on vibrations of the fiber, you can detect exactly what kind of vibration is going on. This is a fantastic opportunity for AI machine learning. Get a whole bunch of training data of vehicles and different types of animals and different types of bipeds and different types of movements of humans so that you can actually figure out where along the perimeter exact types of movement might be happening and what it might be caused by. Now, this might be asking a lot, but even those ridiculously crude suspended magnet geophones back in Vietnam could detect the difference between bicycles, human traffic, even low-flying helicopters. So the sensitivity of tiny vibrations along 50 miles of optical fiber could reveal an awful lot. And remember, this stuff is basically invisible. The way that a lot of these fiber intrusion system detections are used are on big, expensive institutions. So around prisons is kind of an obvious one. But because this is intrinsically safe, non-electrical stuff, it also gets used at power plants and oil refineries, places where pipelines might be run, stuff where you don't want a spark. You want something that is incredibly safe and totally inert. Glass, plastic, fiber buried around this stuff, and it's never going to cause an issue. And it's remarkably safe. It's great to put around electrical substations because arcing and pulses that might be emitted from these things, electrical interference from transformers, not going to affect the photons inside of this thing. So it is a fantastic way to protect some of these larger institutional targets. And you can buy this stuff off of the rack right now. The problem is it does have a military commercial industrial price tag attached to it. And since this fiber itself is very cheap, I would just like the control units to be more available. And this is the sort of thing that I'd like to bring down to the consumer or citizen level right now for a couple of reasons. Number one, as I said, I think it's a great way to get detection around the Tennessee jungle for my property. You know, T-Rex, my house, it could be affordable for everything. The other is that the way that we have done security systems for the last 10 or 15 years has predominantly been dependent on security cameras, cheap Chinese security cameras that let us capture a lot of data. And that's been a great strategy in a lot of ways. Images are great, humans can read them, and artificial intelligence devices are pretty good at picking out stuff inside of camera feeds as well. I was at a big facility, I'll just say a big facility that had a large control room with thousands of cameras, and thanks to some AI object and person gate and activity recognition AI tools, one or two guys could keep a pretty good eye on multi-thousand cameras in that very large space. It's a very cool way to do security and awareness. But with tariffs, supply chain issues, manufacturing issues, I don't know that we can assume that we're always going to be able to just get tens of thousands or millions of cheap Chinese security cameras at any given time. Being able to look at miles upon miles of perimeter activity using just cheap optical fiber that we make here, and the controllers that examine and detect those changes might be a better thing for us to build locally manufactured. We do locally manufacture a lot of this fiber. So the only question is, how can we build a cheaper, more capable way of doing the intrusion detection and the seismic sensing? Because I just want to have this capability. This is one of these things that I've read about for years, and it's just such a fantastic solution for a lot of different things. Now, all of these are going to be trade-offs. The ability to send data over fiber is tremendous, but the ability to send data wirelessly through the air or over satellites is also fantastic. There's going to be strengths and weaknesses across the way. This optical fiber is surprisingly tough, and once you bury it in the ground, it is almost indetectable. It's not going to be affected by lightning strikes. It's not going to be affected by electromagnetic pulses or sunspots or any of the other things that affect radio communication. On the other hand, it is going to be affected by earthquakes. Easily could snap this or damage it in some way. If you string it up between the trees, that works great too, until, you know, a storm blows some of them over. That's how we lose most of our fiber internet here in Tennessee right now. On the other hand, the radio waves are not affected by those things for the most part, but they're really easy to intercept and they're really easy to manipulate. And then sometimes those electromagnetic activities, solar flares and things like that, those do affect them. So a system that uses multiple things is great, but getting more more capability out of our fiber optics than just basic intranet for corporate internet stuff would be fantastic, and I'd love to see some American manufacturing companies lean into the intrusion detection side for security systems, both large and small, and some communication stuff. The ability to run field telephones over this, possibly even the same line that you're doing your seismic detection of your different run area. That's an interesting capability as well. And then there's a third capability that we should probably look at, and that is gyroscopes. One of the issues that you see with the drones over in Ukraine is not just that the command and control signals are being jammed, not just that the video signals back to the pilots are being hijacked. The GPS system that they use for stabilization and navigation, those are also being manipulated by electronic warfare capabilities. Now, you can have inertial guidance based on accelerometers and gyroscopes, but your accuracy at controlling a drone or navigating a vehicle or even just yourself through the jungle without GPS capability is going to be limited by the accuracy of your other instruments, your compasses, your gyros, your accelerometers, whatever it is that you are using. There is another fiber optic device that is extremely cool, which is called a laser or fiber gyro. Essentially, it's doing almost exactly the same thing as that seismic detection device. But instead, what you do is a couple of miles of fiber optic cable in a coil, and you shoot light along it, and any movement of the gyro is going to be detected back at the detector end. So if you have 3 loops, one for bank, one for pitch, and one for heading, you now have incredible accuracy for navigation, far greater than you currently get with the gyros and accelerometers in your phone. Now, these are already used, of course, by military devices. Because they're less susceptible to mechanical shocks, they're often used in howitzers and other field gun emplacements. But again, this is a technology that I'd like to bring down in its cost and application to other people. And one of the best places for it to be used right now, probably in the virtual reality sphere. A lot of the virtual reality tracking that we do of headsets and controllers and various other weapons and devices is done using the exact same accelerometers that you have in your phone. And all the drift and all the inaccuracy gets corrected using camera tracking. Well, sometimes camera tracking is not available. There's plenty of circumstances where it's dark or you just can't rely on those things. So having more reliable gyros for some of these things, that becomes really, really useful for different applications. So there's all kinds of ways in which these really simple capabilities, if we figured out how to bring the cost down, manufacture them locally, and apply them to some different requirements and needs, I think would open a whole bunch of new possibilities. I mean, I say new. A whole bunch of possibilities from the 1980s that have already been written about in National Geographic. Now, if you're watching this video as just an average YouTube enjoyer and consumer, you're probably asking where you can buy these things. But what we're doing here at T-Rex Labs is more than just trying to create an interest and a market for some of the stuff that doesn't exist yet. Over the last year, or however long T-Rex Labs has been going, we've made a number of very interesting contacts and built some relationships with a bunch of companies who are actually in this work of taking large military, commercial, industrial stuff and trying to make it more available, or stuff that is made overseas and try to bring it back here where it is made locally for us. So my hope is that these conversations are not just kind of whetting your appetite for stuff that never exists, but it builds some ideas and some connections with other folks. The fact is that right now, today, technically T-Rex could afford to go out and buy a $20,000 or $30,000 seismic detection system that uses fiber optics from a large company that sells directly to large companies. Like, I could do that and not make this video, but I would much rather that we actually push for some of this technology that is currently up here and bring it down a little bit, which happens sometimes very quickly. This device is an example of that. This is a 3-axis camera stabilization device from our favorite Chinese-controlled drone company DJI. This kind of stabilization used to be an incredibly complicated bit of math and mechanical engineering that was very hard to come by and only made by a few people and incredibly expensive. Now it is a solved problem. It's still mechanically complicated, but it's only a couple of $100, and a bunch of people are in this space making things for regular consumers. And speaking of laser communications. If this thing had not just a camera in it, but a little laser, maybe infrared or dialed into a specific frequency that this camera is particularly sensitive to, this thing could scan all around looking for other laser pulses. And then we could do direct digital communication right through the air without using the fiber. You could mount it on your shoulder like a Predator. That's probably a bad idea, but on a vehicle, something like this would be very interesting. Maybe under a little dome to protect it. Like anywhere your vehicles go, it can look around, find other optical devices like this, and then gigabits per second of speed through the air, almost undetectable, completely unjammable. Few $100. It's possible. You know, old National Geographics are way cooler than you might expect. The recent magazines are kind of terrible. They're written by professional writers who have come out of terrible institutions. They're just think pieces for the most part about the frontiers of the mind or whatever. But the National Geographic Society used to be run by honest-to-goodness explorers, and the people writing the articles were going to incredible places and doing incredible stuff. If you want to learn more about Vietnam from people who were actually there, National Geographic used to publish those articles. Stuff from the 60s in particular is neat because it's a whole bunch of guys who just got back from fighting World War II, going out to some of the most dangerous places in the world, working on some of the biggest and most complicated archaeological and engineering projects, and just writing about it, what they saw with their own eyes. There's an adventure to it that doesn't exist anymore. We need to get back to that somehow, just while we're on the topic of things that need to get done. Maybe you should work on that.